A very good day. My name is Kunur Esmadia binti Ismail. I am from Group 2 of the Red Box. Our project is air fryer. This is my group member, Muhammad Hilmi bin Muhammad, Samsuni anak perempuan Ipin, and also Lee Yo Chun. For the input of our project is the temperature and also the moisture of the food. For the output, it is crispy and also the buzzer. This is our state diagram. For the first state diagram, which is 0, 0, we represent it as the weight. The second is 0, 1, which is 1/4 half cook, 1, 0, 2/4 half cook, and the lastly is 1, 1, 3/4 half cook. For the first state diagram, which is weight, it will go to the next state if the condition is 1, 0, which is temperature is high and the moisture is low. It will be looping to itself if the condition is 0, 0, which is temperature is low, moisture is low, and the 0, 1, which is temperature is low, moisture is high, and 1, 1, temperature is high and the moisture is high. For the second state, which is 1/4 half cook, it also will go to the next state if the temperature is high and the moisture is low. And it will also looping to itself if the condition is 0, 0, 0, 1, and 1, 1. For the third state, 2/4 half cook, it also will go to the next state if the condition is 1, 0, and it will looping to itself if the condition is 0, 0, 0, 1, and 1, 1. For the last state, it also will go to the first state, which is weight, if the condition is 1, 0, and it will looping to itself if the condition is 0, 0, 0, 1, and 1, 1. That's all for me. Thank you.
My name is Samsuni. I'm presenting our ESC project and continue points. So here is our truth table. As you can see, the truth table is actually coming from the state diagram. So here you can see that for the first state, the 0, 0, it will only go to the second state, which is 0, 1, only if it's 1, 0, right? So here in the state diagram and here in the truth table, as you can see here, only when the input is 1 and 0, and the first state 0, 0 is only will go to 0, 1. Others than that is looping itself. So it's here goes the same to other state. And for the fourth state, it will for the input 1 and 0, it will go to 0, 0, which is set back for the first state. As for the output, it will only have the high output when the crispy, when the input is 1 and 0, so the crispy is 1 and the buzzer also is 1. For the next is the K mapping. From the truth table, you can do the K mapping. So we will look up for the most right, so it's 4. So that is 4, 2, 1, and you can form the equation. Yeah, that's all.
Assalamualaikum. My name is Muhammad Hilmi bin Muhammad and I'm from Group 2 Red Box. And now I'm going to present about logic circuit. So firstly we need to draw our state memory. So for our fryer, for air fryer, we need to have 2 flip-flops and then we have to label it. The first one is Q0 current state and the other one is Q1 current state. And we also need to name the input and the output for the flip-flop. Like this one, I name it Q1 current state and Q1 not current state, and for the input is Q1 next state. Next is the state logic. State logic for the Q1 next state, and it has two communication logic that produce Q not next state and Q1 next state, and it comes directly from our logic expression in KMath. And finally, we need the output logic, one that produces the crispy and the other one that produces buzzer. This output also comes directly from our logic expression in KMath. And for the whole logic circuit, we can see we have two inputs. One is T for temperature and M for moisture, and the output is crispy and buzzer.
Hi, my name is Lee Yong Guan, and I will be presenting the part about the simulation for siling in this ESD project. And here I will be showing you the presentation. Alright, so here is the coding siling for the ESD project, and as you can see here, this will be the module for air fryer. So we have two input here, temperature and moisture, and this is clock and reset. For the output, it will be crispy and buzzer, and this will be defined for the current state and the next state. For the parameter, we will be defining the possible output from S0 to S1, S2 and S3. And here it means that when its current state, it will go to S0, and S0 will be when the state is 0 and 0. While if else begin, the current state will move on to next state, which is S1 from S0 or S2 from S1. From here, we define the default state as 0, 0, and the condition for the sequence to move on to the next one is that when temperature is 1 and moisture is 0. So whenever the input is 1, 0 for temperature and moisture, it will begin the next state. If for S0, the next state will be S1, and the output will be 0, 1 for crispy and buzzer. It will goes on until it reaches the S3 state. At S3, when it receives temperature 1 and moisture 0, it will go on to next state, S0 reset, and it will output 1, 1 on crispy and buzzer. Whenever the input is not 1 from temperature or 0 from moisture, it will remain at the state which is, for example, S3, it will remain at S3. Here, the default state is at S0, and the crispy and buzzer is 0, 0. And next, we will see about the test feature. In here, test feature, the input is temperature, moisture, and clock and reset. It's the same as the previous coding. So at the beginning part, we define the clock period, and then we initiate the unit input and output here. After that, we initiate the clock here, and also initiating the input initializes the input here, temperature 0 and clock and 0. For this part, it means that when reset is equal to 1, then it will, and reset is equal to 0. From here, the simulation part, we list out all the possible output, the input from 0, 1, 1, 0, 1, 1 and 0, 0. And there are 16 possible input for 4 different states from S0, S1, S2 and S3. Here we will show you about the test feature. From here you can behavioral check syntax and simulate behavioral model. From the binary sequence, you can see that there are 16 states. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. At the 15th state, this will be our last output when crispy is 1 and buzzer is 0. Buzzer is 1, and the next state when temperature 1 and moisture 1, it will go back, reset at the same state, which is S3. And that's all. That is